go there. Come on. There we go. All right, distance and midpoint. Again, review. You've done this already. Right?
Yeah.
You know the distance formula. What we're going to do today, which I'm guessing you probably have never done, is show you where the distance formula comes from. I'm guessing last year, when you did algebra, your teacher just gave you the distance formula and said, here it is, plug and chug some numbers in and get a distance, correct?
Yeah,
pretty
Good.
much.
Good. Well, we're not going to do that today. But first things first, we need a pen that works. There we go. Pythagorean theorem. So that's a right triangle. Now, we're putting the cart before the horse a little bit. So you'll recall last week I said, unless we know what a term is, we're not going to use it. We're making an exception to the rule. We want to start using Pythagorean theorem early to do a bunch of calculations. So we have to ignore the fact that we don't necessarily know what a triangle is, but we do know what a triangle is. Not only do we know what a triangle is, we know what a right triangle is. So we're going to pretend we've defined that already, and we'll come back around to that later on. Anybody know what Pythagorean theorem is? Go.
A
Name.
squared plus Jalen.
Jalen.
A squared plus B squared equals C squared.
Beautiful. Whoops, didn't want to do that. That's what I wanted. That's actually the Pythagorean theorem. The sum of the squares of the measures of the legs is equal to the square of the measure of the hypotenuse. However, as Jalen said, most people know it's a squared plus b squared equals c squared. You have to be careful, however, that your triangle is labeled correctly. This is the hypotenuse, yes? How do you find the hypotenuse in a right triangle? Two ways. Number one is the longest side, and number two? Across from the right angle. Great. These guys are called legs. That's the hypotenuse. Take the leg, square it. Add it to the other leg, square it. It has to equal the hypotenuse squared. But you knew this already, right? Yeah. Good. The only reason we did Pythagorean theorem is we need Pythagorean theorem for this guy, the distance formula. So this is going to be fun. And all of this hinges on one simple question that you guys are going to have to figure out. So I took a grid, also known as, not
Graph.
what kind of graph?
Line graph.
Nope.
Something with a C.
Something with a C. Very good. Danielle. Natalie, I was close. Is there a Danielle in here? I'm in a completely wrong class then. Natalie. They both have A's in it though.
Coordinate plane.
What kind of coordinate plane?
A Cartesian.
Beautiful. Cartesian coordinate plane named after?
The one dude.
That one dude. Good. Try that on the next test. Rene Descartes. I heard somebody say it. All right. So we're going to take two random points. Don't worry about where they are on the grid. Don't worry about the fact that they're in the first quadrant. Just 2 points. I slapped them on the grid there. I called one point x1, y1, and the other point x2, y2. Okay. Ideally, what I'd like to be able to do is find the distance between those 2 points, which I labeled as lowercase d. And you're probably already, some of you in your head are already going through the distance formula of d is equal to the square, blah, blah, blah. But we'll get there eventually. All right, here's the big question for you. How long is that red segment? And again, it doesn't matter where x1 and y1 is. So don't tell me it's 1, 2, 3, 4, 5, 6, 7 units long. I'm not looking for a number. I'm looking for an expression as to how long that red segment is. And this is not an easy question. But it is paramount in us solving the problem. Name, please.
Tommy.
Tommy, what do you got for me?
Y1 minus Y2.
Oh, beautiful. Let's give it up for Tommy, huh? Explain that.
Well,
What, did the math gods just beam the answer into your brain?
Y1 is the highest distance of that leg, and Y is the lowest distance of that leg. Subtract them to find the length of it.
Beautiful. It's a vertical segment. It has no change in x. It's not moving left and right at all. It's just moving up and down. So this height is y1, because it says right there. This distance is, or this location is y2, so therefore that distance would be y1 minus y2. And thankfully Tommy did the hard work, so the rest of it is easy. That distance, as he said, is y1 minus y2. And since you're in advanced honors, accelerated, whatever this class is called, you should be good at pattern recognition and be able to tell me how long is that blue segment. Tommy, since you started this mess,
x1 minus x2.
attaboy. All right. What kind of triangle do I have there with the red segment, the blue segment, and the black segment?
A right triangle.
A right triangle, and as we learned from the previous slide, the Pythagorean theorem applies to a right triangle, does it not? Right. So, I just kind of jumped ahead for a second, so I'm going to write it down so that you can all see it. But if I apply Pythagorean theorem here, I get one leg squared, we'll do that one, x1 minus x2 quantity squared, plus the other leg squared, y1 minus y2 quantity squared, and that has to equal the hypotenuse squared. I lose anybody? We good? But notice I don't want to know what d squared is, I want to know what d is, so how do I get d by itself?
Square root of that number.
Take the square root of the whole thing. Yeah, so take the square root of this side, take the square root of that side. What's the square root of d squared? D. And so we get rid of that, click on a couple more buttons, and lo and behold, we have the distance formula. Remember, minus is inside the parentheses, plus is outside the parentheses. And when you take the square root, you always take the positive value, because in this class, negative distance doesn't make any sense. There are such things as negative distances, but not for us. You'll see those when you get to physics. They're called vectors. And they're fun. Okay, got it? Now, eventually, we're going to be using the calculator a lot more. We're going to integrate the calculator into our work and our lessons and stuff like that. And I'm going to give you a bunch of programs for that calculator that does a bunch of work for you. But until that stage, we're going to have to be able to do this by hand. Which means you can use your calculators. In fact, you'll need your calculators. Go ahead and get those out. But I'm not going to have a program for you yet. All right, so we'll start with that guy. Find the exact distance. So I'm going to talk about exact distance and approximate distance. Exact distance should have a square root in it or be a nice, pretty whole number. Okay. Approximate distance, which we'll get to in number 2, will be the decimal value you'll punch into your calculator. Okay, so do that one first. Set it up first on your paper, then start plugging it into your calculator. Have the calculator do the math for you. And actually, for this first one, you probably won't need your calculator, but you can all add and subtract numbers. Notice I didn't tell you which one to make x1, y1, and which one to make x2, y2, because it works either way.
Yes. This
No, not this year, but in the past.
yeah.
Yeah.
Many.
Yeah.
That's my favorite song.
Oh, nice. That's classic.
Yeah.
You go to any this season?
Yeah.
Which ones?
I think. No, I'm not sure yet. I don't know what.
We're doing Duke, Miami, and Virginia Tech. It's a good time. Oh. Shazam. Be careful on your math, kids. blue, is that okay, or do you have a color preference?
It's fine.
Blue's okay?
Yeah.
All right. Write nice and big so we can see it.
Do I have to write the formula out?
Did you buy this like this, or is this a custom job? I've never seen it. That's okay. This is still really cool. Good looking over here. Sorry, you asked me a question. I was distracted by the awesome calculator cover.
Oh, it's okay.
Nice, let's give it up, huh? Well done. Tell me your name again. Joanna. So she starts with the blank formula. Not a bad idea to start. She chose one of the points. So she chose this to be x2, y2, and this to be x1, y1, which is fine. You didn't have to. You could do it the other way. You get the same answers. Plug the numbers in. Simplify. 7 squared is 49 plus 1 squared square root of 50. And then, of course, based on what we talked about the other day, that's not an acceptable answer because that radical could be simplified down to 5 square roots of 2. Now, if you have 7.07, I think it is, did anybody get decimal value? That would be an approximate answer. Save that for the last one. So your answer should be 5 square roots of 2. Any problems with that? If you made a mistake, I'm guessing it happened in this area here. Either setting it up or doing some simple addition and subtraction. Most of you are pretty good at squaring numbers and adding numbers. Remember also what we learned from this worksheet the other day, that this does not equal 7 plus negative 1. Okay, the square root and the squares don't cancel. You have to do it just like Joanna did. Questions on that before I erase it? Hot diggity. Let's try another one. Now approximate distance. Set it up, plug it in, get it down to a square root, and then boom, take an approximate answer on your calculator. So if you get something like the square root of 105, then plug the square root of 105 in your calculator. Let's take a decimal equivalent out to 2 decimal places. That'll be our standard. Good, good. When you get your answer, look over at your neighbors, see if they have the same answer. If not, figure out who made a mistake. Maybe both of you made a mistake. That could happen. right? Oh, that hurt, didn't it? Okay. Square root of 194, which is 13.93. Are we good? Anybody have trouble and want me to set it up for you? Speak now or forever hold your peace. Okay, remember we're rounding to 2 decimal places, so that third spot you need to look at. If it's 5 or greater, it rounds up. If it's less than 5, it stays the same. You sure? We're good? Excellent. All right, what's a midpoint? Oh, we heard from you already. Call the police. Haven't we heard from you? Tell me your name. We've heard from you, right? No, we used you as a demonstration for between. All right, what's a midpoint?
Midpoint is distance, and there are 2 points. It's the place right between them.
If you have 2 points, it's the place right between them. Oh, exactly in the middle. Well, you added some more on there. So if you have 2 points, it's the space, or it's the point exactly in the middle. How's that sound? Did you get that? Between 2 points, it's the point that's exactly in the middle. Are we good with that? Okay, let me draw a picture then. Oh, I don't want to do that. Let's do this. That was weird. You saw that too, right?
No. I didn't like that.
This isn't gonna work. Okay, what about this guy? Is that exactly in the middle?
It has to be on the line segment.
Oh, it has to be on the segment connecting the two. Okay. Oh, what the heck? Let's try it. Sure, why not? Oh, that's great. Oh, that worked. Okay. So it's got to be on the line segment now. So let's call this X, Y. Oh, all of a sudden things fix itself. We're good. It's got to be on the line segment, exactly in the middle. Does that look like it's exactly in the middle? If it is exactly in the middle, what must be true?
They're equal. Like
Done. Okay, hold on. Pronouns bad. Don't use it, they, their. Be specific.
well, each half of the line segment is equal.
Good. Name the halves of the line segment.
XM and MY is equal.
Perfect. Got it? Okay, so she said you have a midpoint is a point on a segment exactly in the middle of that segment, and this half has to equal that half. In other words, XM has to equal MY. Are we all in agreement? Is she missing anything?
On each side it will have the dashes. Same.
Good. But is that necessary for the definition? That's good, and we're going to use that for the graphical picture. You remember what those things are called? It's a little bug that bites and gets under your skin, and then, yeah, tick marks. Okay, so we can denote that by doing that. Very good. So again, is she missing anything in her definition, and or does she have too much in her definition? Or is it rock solid? 3 choices.
I think it's pretty well.
I think it's really good, so we're going to go with it. Which is basically what she just said. We don't want to use the word between when we're talking about midpoints. Or I shouldn't say that. We don't want to just use the word between when we talk about midpoints because there are a whole bunch of points between the 2 points. There's only one midpoint. Okay, so it's a specific point between there. And I got a little picture like that. And like she said, we got some tick marks to show that in the picture. Unless you're told it's a midpoint, or you're told that those 2 segments are equal, we cannot assume that it's a midpoint. Okay, there's got to be some information there. And you're going to be looking at problems where you have to test whether or not a point is a midpoint by doing some algebra. Are we solid here? Good. Blah, 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 blah. On a coordinate plane, we want to find the midpoint. Does anybody remember the midpoint formula? Go.
x1 plus x2 divided by 2 is the x coordinate, and then y1 plus y2 1.
Beautiful. Nice. Give it up. Remember the midpoint formula. Take the average of the x's, take the average of the y's. You have the coordinates of the midpoint. So again, talking about notes, I would not write down this first paragraph. I would pretty much on this slide just copy down the formula. Okay, midpoint is found by taking the average of the x's and the average of the y's. And again, I think you knew this already, right? Yeah. Good. We'll start with something simple. Find the coordinates of the midpoint of ST given S and T's locations. Common mistake when we talk about this lesson is people get distance formula confused with midpoint. When you're doing a distance formula, your answer should be a number, singular. When you're doing a midpoint, you need two answers because they're the coordinates of the points. Christian, where are you? Where's the midpoint? Does anybody have negative 5.5 comma negative 3.5? Raise your hand if you do. Or if you prefer negative 11 halves or negative 7 halves. We seem to be in agreement there. We'll go with that. 3 plus negative 14 is negative 11, divided by 2 is negative 11 halves, or you could convert that to a decimal because it's a nice pretty decimal of 5.5. 2 plus negative 9 is negative 7, divided by 2 is negative 7 halves, or again, if you prefer, negative 3.5. This one gets a little bit weirder. Now I've given you the midpoint and one of the endpoints, and you need to find the other endpoint. Again, being a visual learner, I'm going to draw a picture. I've got K over here, I've got M right here, and I'm looking for L. So I know that K is at 1, 2, and I know that M is at 5, negative 6. I'll show you two ways to solve the problem. One way is the algebraic way, which is prettier and more appropriate, but then I'll also show you the realistic way to solve it. Okay, we'll do the harder one first. We'll do the algebra. We don't know where L is, so let's call L xy. If I knew where L was, then to find the midpoint, I would take the two x coordinates, add them up, divide by 2. I would take the two x coordinates, add them up, divide by 2, and that would give me the coordinate of the midpoint. Are you with me there? Okay, so multiply by 2, subtract 1, so x would be equal to negative 9. If I knew where L was, I would take the two y coordinates, add them up, divide by 2. Uh-oh, here we go again. Divide by 2, and that would give you the y coordinate of the midpoint. Let's see, move that over there. It's negative 12 minus 2 is y is equal to negative 14. Okay, so I should get negative 9 comma negative 14 as my answer using the cheater method. Does that make sense to everybody before I show you the easy way? Okay, here's the easy way. What did I do to go from 1 to 5?
Plus 4.
Added 4. 5 plus 4. Wait a second. Did I make a mistake? I did. This should be positive 9. Duh. 10 minus 1 is 9, not negative 9. Thanks for leaving me blowing in the breeze there, jerks. Somebody could have said that's not right. Did you legitimately not see that?
No.
Or you just figured you knew what I was doing because I'm a math teacher? Yeah, don't make that assumption. What do you do to go from 2 to negative 6?
Minus 8.
Minus 8. Negative 6 minus 8? This one I got correct. Yes, to feel good. All right, 9, negative 14. This is a little bit easier to do. Nice, quick, easy method to solve those problems. Still would recommend this picture though, because that picture is going to allow you to see those kind of things. It doesn't have to be graphed on a coordinate, Cartesian coordinate plane to be accurate. You just need a visualization of what's going on. Are we good? Yes. Beautiful. One more. Draw a picture, plug in your algebra, solve some algebra, get an answer, check to make sure that answer makes sense. Don't want any craziness going on there. I'm sorry? Yeah, it's just telling me that I did this thing. Happens all the time. When I take the cap off, it'll then tell me it's going to be good. I assume you've drawn the picture by now. I hope. Plus 2. And how long's PO? Say it loud, say it proud. Who's talking? I hear mumbling. Natalie, was that you?
Yeah,
Okay, what is it?
said shouldn't it be the same distance?
So?
PO, is 6 minus the x.
Beautiful. So if you want to solve the problem like we did last week, you could add up the two small pieces together and set it equal to the big one. 6 minus 3x plus 6 minus 3x is equal to 14x plus 2. Solve. Easy peasy lemon squeezy. However, if you were feeling saucy, how could I, let's suppose I couldn't figure that out, and I just want to use that, what other equation could I set up? Thomas. But I forget what you go by. He's Tommy. What are you? You don't care? Wendy.
What did you do, like 14x plus 2? Oh wait.
How long do I have to wait?
Would you do 14x plus 2 minus 6
Am I done waiting?
minus 3x?
Is that a yes or no?
I think I messed up.
My leg's starting to cramp.
Yeah. Sorry.
That's okay. Anybody else? No. You okay?
No.
No? Are you gonna cry? There's Kleenex up here. How about this? Same thing. Okay. Solve it for x. What does x turn out to be?
6 minus 3x.
Say again?
6 minus 3x.
No, what does x turn out to be
Oh.
when you solve the algebra? Well, this is awkward. Okay, so, which is it? Hey, I'm sorry?
It's 2.
Oh, I thought you were saying like peace. So that was your subtle way of telling me the answer is 2? Okay, that was good. I like that. 2, anybody else want to confirm? Is she the only one that can do simple algebra? Good, let's give it up. Nice job. You're gonna make a lot of friends in here, because if they can't do algebra, they're gonna be looking for help from you. I'm gonna trust you, you have an honest face, and nobody else can talk, so we're gonna go with x equals 2. That doesn't answer the question though, right? It says what's PO. So then what? 0
Yeah, I did that wrong.
can't be 0. Right, so this is an excellent example. She got x equals 2. We'll cover that in a second. Plugs it back in, and now all of a sudden a problem happens, because when you plug in 2 here, this goes to 0. But if I plug in 2 here, I get 30. 0 plus 0 can't equal 30. So that's an indication that we made a mistake somewhere. So, what's the mistake? What do you got?
I thought x equals 0.5.
0.5? Anybody else? Okay, so why didn't you say something? Just sit there like bumps on a log? Did you divide wrong?
Yeah.
Yeah, 0.5. Let's see, 0.5 would be 0.5 times 3, so this would be 4.5, which would make this 4.5. And just to make sure, 0.5 times 14 is 7 plus 2 is 9er. 4.5 plus 4.5 is 9, so I like that answer. So what's the ultimate answer to the question?
4.5.
4.5, because it wants to know what is PO. And therefore, 4.5. Okie doke. So a little different than the betweenness problems. Remember, the betweenness problems, you add up the two parts and set them equal to the big part. In the midpoint, you don't necessarily know all the parts. Oh, look, I have all the work here. I could have just done this, 0.5. Okay, so, segment bisector. Bisector means what? Bi means 2. Sect means sect. Notice I enunciated there. Means to cut. So a segment bisector is something that cuts a segment in half. It could be a midpoint. It could be a line or another segment. It could even be a big honking plane. But it's just something that chops a segment in half. In other words, it passes through the midpoint. I think we're done now. We are done. Day 5. Any questions?
Just so happy to be doing homework.
Yeah. It's kind
That's
of,
not what
where's-
happens.
kind of a
where's his
creepy
nose?
picture I found for you today.
Where's his
No,
nose?
you go back.
He doesn't have his nose. He lost it in a gardening accident. Right.
He wanted you to know.
Stop child labor. Kids lose their noses in gardens.
You would think once he lost his nose, he wouldn't have to work anymore, but
Nah. Gotta feed his family, man.
Maybe the nose just appeared.